The United States Fire Administration asked us to examine the potential for developing a flashover prevention system for residential structures. The USFA many decades ago sponsored a significant amount of research to develop residential sprinklers. The idea is to take another look and see if there's a way that sprinklers could be optimized, or the water used in the system could be optimized in such a way that it could be run off a domestic system, requiring much lower amounts of water and low pressures, as opposed to requiring any kind of special equipment to be added to the water supply of the home. So we're planning a series of tests where we're going to examine the ability for differing amounts of water and water spray patterns to cool the gases that are generated from a room fire. And then in other cases, we're going to look at what happens if the water is actually cooling the fuel that initially ignited and is starting to burn in a room fire. The gas cooling tests will all be conducted with propane-fired burners. Then we're going to put furnishings into the fire room. Basically a single piece of furniture, an upholstered sofa, sitting on a carpeted floor with padding underneath and a subfloor of oriented strand board. In these cases, we're going to ignite the fire with a small matchbook, an electric match, small flaming source, and watch the fire develop until the point where the sprinkler activates. So in one case, we have a sprinkler activation with a sprinkler that's going to flow 9 gallons per minute, and that's going to be our baseline of what we would expect or what we would like to have with these water spray nozzles. Then we'll move on to water spray nozzles flowing approximately 6 gallons a minute and as low as perhaps 3 gallons a minute to see how well they stand up to the challenge of the burning sofa. Last but not least, we'll run an experiment where we ignite the sofa and we have no fire suppression system at all, just to benchmark how fast conditions become untenable for any citizens that might be in that room or in an adjacent room. What we hope to learn from these tests is there potential for designing a system with much lower water flow rates than are currently required by a 13D system that have the potential to provide additional egress time, to prevent flashover, provide some level of fire safety for people that aren't going to get that level of fire safety any other way, in terms of retrofitting a structure or maybe special use structures that might be able to make great use of a specialized system with a really low water flow rate that targets the fuels that are in the home and stops that fire in its tracks very early before it gets to producing hazardous conditions within the structure.